Okay folks, this is our final video in this pre-work, our introduction to logarithms. So we've introduced the idea of a logarithm, we've had a little practice, and we just want to increase our fluency with them. So we've seen before these following facts, that the log base 4 of 64 is equal to 3, and that 4 to the third power is equal to 64. That these are, we could call these equivalent facts. I call these two facts equivalent inverse statements. So in these problems here, I'm giving you a statement, and I'd like you to give the expressions equivalent inverse statement in terms of the either exponential equation or logarithmic equation. So for example, this is actually our definition of a logarithm. How would I write this as an exponent? I would write this as a to the n is equal to m. And that was actually, if you go back earlier, that was just our definition. Remember I said that was the essential definition that you have to know to be able to work with logarithms. In B here, I didn't give you a logarithmic equation. Instead, I gave you an exponential equation, and I want you to convert this exponential equation back to a logarithmic equation. So the base in this would be x of the number z would return the power y. Okay? And again, I'm just using this expression here as sort of a decoder until I get fluent with this. Here we've got a fact, and you can confirm that this fact is true, that the log base 3 of 81 is equal to 4. This is a logarithmic equation. What's its equivalent inverse statement? Its equivalent inverse statement is that 3 to the fourth power is equal to 81. So keep in mind here, this is the first one that's been a little more straightforward, that here's our base, so the base of the exponent is 3, the same way that was. And then here we have the what the exponent evaluates to, just like we had here. So the exponent evaluates to the number 81. And so we ask the question, 3 to what power equals 81? And that answer is 4. So the exponent is what the logarithm's equal to, and that's the power there for that statement. Okay? So this is a little bit hard, folks. You've got 3 different components to keep track of as you're rearranging these logarithmic statements or these logarithmic equations as exponential equations. My piece of advice is to notice that the base a of the exponent is the base of the the base of the logarithm is the base of the exponent. That's the same thing. And so there's not actually all that much that you have to keep track of in following this definition. But keep working at it, because I think it is challenging at first. So here we've got the question 81 to the 1/4 power is equal to 3. We've got this logarithmic equation here, this exponential equation, and we want to rewrite it as its equivalent logarithmic equation. So don't fall into the trap here, folks. What's the base of this exponent? The base of the exponent is 81. And we would say that when we take 81 to the to the 1/4 power, we would get 3. So this is the equivalent. Here's our exponential equation. Here's our equivalent logarithmic equation, where we ask the question here. Here we say 81 to what power equals 3? And the answer is, well, and another way to say that is that the fourth root of 81 is equal to 3. And if I think of that as an exponent, that would be 81 to the 1/4 power is equal to 3. Okay. So here we have these two implied bases. Remember, this part's a little bit tricky, folks, because these are implied bases. Here we've got the log of 1,000 is equal to 3. Again, what's the understood base of this exponent? I sort of wish that we would write it this way. I think it would make students' lives easier. It'd make my life easier, as I'd have less to explain. I wish we wrote log base 10 of 1,000 equals 3, but we just write log and we say that the base 10 is implied. So this is my logarithmic fact, and I want its equivalent inverse fact. I want the equivalent inverse statement, which would be that 10 to the third power is equal to 1,000. Unfortunately, there's not a lot of nice numbers that we can evaluate on the exponential function, but if we have e to the third power is approximately 20, then we know that the natural log of 20 is approximately 3. Keep in mind that this is that implied base e that we talked about in the previous video. If you thought of this as log base e of 20, is approximately 3. There's nothing wrong with thinking about it that way, but just know that we will always write natural log instead of log base e, and that's just an old holdover of old notation. So I've just worked these 6 problems. You have 6 sort of equivalent problems here. They're not necessarily in the same order, but I'm asking you to try these on your own. And then I'd like you to go ahead and also do number 23, 24. And then when you're done, I'm going to ask you to work a MyLab Math pre-work on the introduction to logarithms. So this was a short last video, folks. I hope that this was a good introduction to logarithms. If you do have any questions, please don't hesitate to reach out, and I'll see you in the next pre-work.